Hello students, here I am going to continue coordinate geometry exercise 7.2, ninth question. Find the coordinates of the points which divides the line segment joining a minus 2, 2 and b 2, 8 into 4 equal parts. Here there is a segment a, that is 2, minus 2, 2 it is given, b it is given 2, 8, and I will take here midpoint of this px comma y. Again I'll take the midpoint of AP as qx comma y and the midpoint of PB as rx comma y. Now here AQ is equal to QP is equal to PR is equal to RB. That means this line segment divided into 4 equal parts and we want to find out all the coordinates of this. Now first of all we'll find out what is px comma y. Here let px comma y is the midpoint of a minus 2, 2 and b 2, 8. So px comma y, we are using midpoint formula here. x1 plus x2 by 2, y1 plus y2 by 2, that is equal to, this is x1 and y1, x2, y2, we'll use the formula minus 2 plus 2 divided by 2, 2 plus 8 by 2, so we will get 0 by 2 and here 10 by 2 and that is equal to 0, 5 and this is the coordinate of P. Next we'll find out what is qx comma y. Qx comma y is the midpoint of AP. So qx comma y is the midpoint of a minus 2, 2 and p 0, 5 what we got over here. So this is here now x1 y1, this one is x2 y2. We want to find out qx comma y is equal to x1 plus x2 by 2, y1 plus y2 by 2 and that is equal to x1 is minus 2 plus 0 by 2 and here 2 plus 5 by 2 and that is equal to minus 1, 7 by 2 and this is the coordinate of Q. Now we want to find out Rx comma y, which is the midpoint of PB. Rx comma y is the midpoint of P 0, 5 and B 2, 8. So Rx comma y is equal to, using midpoint formula, x1 plus x2 by 2, y1 plus y2 by 2. So we will get here 0 plus 2 by 2, 5 plus 8 by 2, that is 0 plus 2 is 2, 2 by 2 is 1, 8 plus 5 is 13, by 2 is 13 by 2. Therefore, the coordinates of the points which divides a 2, minus 2, 2 and b 2, 8 into 4 equal parts are minus 1, 7 by 2, 0, 5 and 1, 13 by 2. Now we are going to 10th sum. Find the area of the rhombus if its vertices are 3, 0, 4, 5, minus 1, 4 and minus 2, minus 1 taken in order. Here there is a rhombus. I named it as ABCD, and A is 3, 0, B is 4, 5, C is -1, 4, D is -2, -1. Already hint is given here. Area of the rhombus is equal to half into product of the diagonals. So we require to find out both the diagonals AC and BD, and we have to apply the formula. So here we'll write let A be 3, 0, B 4, 5, C is -1, 4, and D -2, -1 are the vertices of the rhombus ABCD. So first we'll find out the diagonal AC. AC is equal to, using the distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is x1 y1, this is x2 y2. So -1 minus 3 the whole square plus 4 minus 0 the whole square. So we will get root of -4 square plus 4 square, that is root of 16 plus 16, that is equal to root 32. When we simplify and write it, it is 4 root 2 units. Next we want to find out BD. Here this is x1 and y1. This is x2, B is x2, y2, I'll take it. Root of 4 minus of minus plus 2 the whole square plus 5 minus 1 the whole square, minus of minus plus 1 the whole square, so we will get here 6 square plus 6 square, 36 plus 36, root 72, that is 6 root 2 units. Length of the diagonals AC we got 4 root 2 units, BD is equal to 6 root 2 units. Now we want to find the area of the rhombus is equal to half into diagonal 1 into diagonal 2, that is half into diagonal 1 I'll consider as AC into diagonal 2 is BD, and that is equal to half into AC is 4 root 2 into BD is 6 root 2. So half into 6 into 4, 24 into root 2 into root 2. When we multiply, we'll get 2. 2 and 2 will get cancelled. So area is 24 square units.